Yeah, from question 15 to question 20, right? Yeah, these 6 questions I told you to try. Now we will start the discussion. Here, last class,
Sir,
the
when our
beginning.
classes will resume again?
What?
When our school class will resume? School class will resume the new session class?
School for the new session starts from 19th. Got it? Hello,
Yes,
Parame?
sir.
And
Yes, sir.
16th will be your result day. 16th will be your result day, and 19th the school will resume for new session. So 15, continue 15.
Yes, sir. 1 kilogram of water needs more thermal energy to raise its temperature by 1 degree Celsius than the kilogram of copper. Why is this? Copper has a higher specific heat capacity than water. Copper has a lower specific heat capacity than water. Copper is a better conductor of heat than water. Copper is a proper conductor of heat than water.
The last
So
one you
copper
read,
is a better conductor of heat than water.
copper is a poorer, huh? Not proper. You read
So
it proper, right? This is poorer.
yes,
Copper
sir.
is a poorer conductor of heat than water. Now your answer is which one?
See,
Uh, you are saying C, right?
yes, sir.
Mm, your the statement, it is correct that copper is a better conductor of heat than water, but the question is asking you something different. That it does not ask you that how it is conducting or which one is becoming more hot, right? They are asking you something related to energy gaining, right?
Yes, sir.
That's related to thermal capacity, heat capacity. So uh, the statement, the question is asking you uh, about thermal capacity, and thermal capacity is related to 1 degree temperature rise, right? You see, they are saying water needs more thermal energy to raise its temperature. That means water can absorb more heat, right?
Yes, sir.
Water can preserve more heat. That's why its capacity is more. So which one should be the answer?
Then yeah, option D. Copper is a poorer conductor of heat than water.
No, it's not related to conductor. It's related to capacity. I told, like
Capacity.
how much it can absorb the heat, how much it can gain the heat, how can it preserve the heat, that capacity. So which one will be the correct option?
Sir, can you repeat the last line you tell?
Yeah, my last line was again I am saying no problem that in the question they are saying water needs more thermal energy to raise its temperature by 1 degree Celsius than 1 kilogram of copper. That means water can absorb more heat, right? Water can
Yes, sir.
preserve more heat. Got my point? So it has more capacity to preserve heat. So which option is here correct?
A. Copper is a higher heat, specific heat capacity.
Copper has higher heat capacity or water has higher heat capacity? Water is
Water has.
water is taking more thermal energy, right?
Water has. Yeah.
So which option will be correct?
B.
C or B?
B. B.
Yeah, B. B for Bangladesh. You see here it's written copper has a lower specific heat capacity than water. So B is the correct option.
Mhm.
Clear now?
Yes, sir.
The question is, not so uh, hard, but the presentation of question is making it harder. Like they did not give it directly the option, right? They could give like water has higher heat capacity, then it could be easier to get. But they gave uh, oppositely that copper has a lower specific heat capacity than water. In question, they first brought water, but in answer, they first brought copper. That's making the question a little bit harder. Otherwise, the question is easy. Now it's clear. Hello.
Yes,
Can we
sir.
go to question 16?
Yes, sir.
Now, 16. Can you read question 16?
The thermal energy produced by an electric heater in 3 minutes is used to melt wax. The wax is initially at its melting point of 60 degrees Celsius.
Mm-hmm.
Specific latent heat of the wax is 220 joule per gram. The heater supplies 7,700 joule of thermal energy to the wax. How much wax melts?
So it's really related to specific latent heat, right?
Uh, Yes, sir.
And we have here energy, and
Yes,
they
sir.
are asking you about the amount of wax melts. So, uh, which formula you will use here? Can you recall? What is the formula of specific latent heat? You can check your copy to see the formula of specific latent heat. We did already two questions on a specific latent heat. So the formula already we discussed while we even solved the worksheet twice.
L equals to Q by M.
Again,
L equals to Q by M.
okay. Then they are asking you L
How much the
equals,
wax melts? Q by M.
they are asking you M, right?
Yes, sir.
Q by M. They are asking you M, right?
Yes,
So
sir.
can you rearrange the formula? If you
L m
rearrange
is
m
Q,
equals q
Q by
by
L.
L. M will come to here and L will go to down, right? Cross
Yes, sir.
multiplication. So write it on your copy. You write it MCQ 16 how to do. Do you have the copy with you?
Yes, sir.
Please write. If you write, it will be a good practice. I told you to practice again and again. Otherwise, Farabi, you cannot answer in the exams.
And sir, how we will get our school report card, sir?
Your report card will be given on 16th.
Sir, how?
They will give you the notice, maybe online or uh, physically your parent will collect from office. Okay,
Okay, sir.
they will give you the notice. Now look, Q is given how much?
Uh,
Which one is Q? Q means heat energy, right? Which one is Q? Which one is L?
sir, I can't hear, sir. Can you repeat?
Yeah, I am asking you, which one is Q? From this
Mm,
question, you should identify the
thermal
values are
energy,
given.
sir.
Huh? Thermal energy. So
Thermal
which
energy.
one? Tell me the value. Tell me the value.
Yeah, 7,700.
Yes, write it here. In your copy also you write. Okay. 7. I'm writing. You also write. 7,700. Then what is the value of L?
Like
Which one is L?
220
220. Very good.
latent heat.
Mm-hmm. So write it. In your copy also you write it. 220.
Answer is
Okay.
35.
35 grams, right?
Yes, sir.
So look, we did many questions on specific latent heat in your class time. During your class time, also we did some questions from book, right, Arabin?
Yes, sir.
And here we did three more questions in worksheet. So by this time, if I get if we get more question, numerical questions on this specific latent heat or specific heat capacity, then you should correctly tell me the formula. You should correctly do the working, right? We expect this one from you. Can we expect it from you, Farabi?
Yes, sir.
So please, I'm reminding you again and again to practice. Otherwise, uh, if you don't practice, you have, mashallah, good brain, you have everything, but you cannot answer in the exam. You have to practice. Got my point?
Yes, sir.
Okay, 17. Continue 17.
What is latent heat of vaporization?
Hmm. So I gave you the definition, right?
Yes.
So what was the definition?
The thermal energy or heat required to change one state to another without any change of temperature.
Okay, without any change of temperature. So they are asking you about vaporization, right?
Yes, sir.
So vaporization, what happens? Change of state from from which state to which state it goes. From solid to liquid or liquid to gas?
Solid to liquid or liquid to gas. It goes from
In latent heat of vaporization, is it from solid to liquid or liquid to gas?
solid to liquid,
Solid to, if it is solid to liquid, then it is latent heat of melting
liquid to gas.
or latent heat of fusion.
Liquid to gas is latent heat of vaporization.
Okay. Liquid to gas. You should
Gas.
write it. You should write it in your copy. Otherwise, tomorrow I ask you, you will forget. MCQ 70, you write
Yes,
latent heat
sir.
of vaporization, give the hyphen, and liquid to gas. Okay. So if it is from liquid to gas, then what happens? Molecules move far apart, right?
Yes, sir.
Because in gas, the molecular space increases. They are going far apart. And one thing I told you many times, that molecules cannot expand. Molecules, uh, they will stay their size same always. What will happen? Molecules move far apart. We can say gas expand, but we cannot say molecules expand. In MCQ 17, please take these notes.
Yes, sir.
That molecules never expand, rather gas expands. After that, you write molecules move far apart. Did you write
Yes, sir.
what you wrote?
So, sir, the molecules move
Hmm.
in solid liquid to gas.
Hmm. Then
I wrote till this.
only this.
Yes, sir.
But later on, I told you to write molecules never expand.
So, molecules never expand.
Molecules never expand. Give comma. Then you write rather gas expands.
Yes, sir.
Then again give comma. So molecules move far apart.
Yes, sir.
So I gave you some information. I gave you 4 points, and you match your answer now with these 4 points. Which one will be your answer? Try to pick the answer. Out of these four options, which one do you think will be correct? Arabi,
Mm.
Arabi,
Yes, sir.
yeah. Which one?
Mm. Sir, B, the energy required to make molecules expand and move apart.
Look, in your copy, I told you to write molecules never expand. Molecules never expand, I
Yes,
told,
sir.
right? So if you wrote that, then how can you choose B? I wrote only gas expands, not molecules expand, right?
Oh my God.
So which one?
Yes, sir. So the energy required to make molecules move apart.
So C, right? C for Cardiff, right?
Yes,
Farabi. So C, right? The answer
yes,
is
sir.
C.
Yes,
The energy required to make molecules move far apart. Clear to you? This one, 17. So do you have any queries in 15, 16, 17? We already discussed.
sir.
Hmm?
No, sir.
You understood. Okay, good. Now we are going to next question. Okay, this one.
An electric shower taken in cold water at 17 degrees Celsius. The shower gives 6,000 joule of energy every second to the cold water and it to it to 37 degrees Celsius. The specific capacity of water is 42, 4,200 joule per kg per degree.
So which formula we'll use now?
Mm, Uh, Sir, specific capacity
Okay, what is the formula? Can you tell me the formula?
is equal to Q by M del theta.
Again,
C equals to Q by M del theta.
C equals to Qy M del theta, right? Okay, so what they are asking you to find?
Mm, the, uh, yeah, mass of hot water.
So how can we rearrange it? We have to make M as the subject, right?
Rearrange it. Yes,
M.
sir.
So what will be the formula then? M equals, yeah, tell me the formula now. M
What the
equals,
formula? M
M e-
equals Q by C del theta.
excellent, excellent. Q by, so write, in your copy also you write. Please write in your copy. Q by C del theta. I am writing, you also write. Write all the steps because it is your note. If you have any scope to print out the worksheet, then it will be easier for you to revise. Okay, during O-level exams.
Yes,
Then,
sir.
then now,
Then sir, Q equals to
what is Q? Q is given
net
here.
capacity. Yeah, 4,200.
Huh?
4,200.
It is Q.
4,200. Yes, sir. Oh, no, sir. Q.
Q is your
Or
energy.
energy, sir.
Hmm. So, which one is your Q? What
Sir,
is
one
the
minute.
unit?
My phone got hanged.
Sorry?
Sir, my phone got hanged. Hanged. I just fixed it. No.
Okay, okay.
The Q energy. Sir, 6,000 joule is Q.
So, write in your copy, you write it 6,000 divided by in C, what will be the value of C?
C.
Mm-hmm.
4,200.
So, write it there in your copy. Then del
And
theta
sir, delta T is same. No, sir.
10 or 20. 37 minus 17. How much?
20.
20. So, why you are saying 10?
Sir, del theta is same word. Na, sir? Del and theta.
Del theta means 37 minus 17. That means,
Understand? Oh,
hmm.
yes.
So 37 minus 17, how much? It is 20.
20.
Why you are saying 10?
Sir, I'm not saying 10. Sir, I just saying the meaning of del theta.
Okay, okay. Change. Then I got it wrong. Maliha, hey Maliha, Maliha, চুলায় কি আছে? তোমার কি পড়া যাচ্ছে? Hmm. So what is your answer now?
Understand Q. Sir, one minute. Let me calculate it.
Yeah, calculate it. Then tell me what is the value.
Q. The 6,000 by 43, 4,200 into 20. No, sir. Sir,
6,000
0.07.
6,000
08.
divided by 20. Then how much it comes? 6,000 by 20.
300. 300 in
300 by 4200. That
0,
means
sir.
3 by 40. 3 by 40, how much?
Sir, 0.71. Option C.
0.071.
Yes. Sir, 0. Yes, sir.
0.071, right? In your calculator, is it coming?
Yes, sir.
0.071. Okay, good. So clear?
Yes, sir.
Look, so many questions we are doing, numerical questions. You are becoming expert, but you have to practice how to rearrange what they are asking, and if you rearrange what will be the formula, then which quantity is what, which one is energy, which one is specific heat capacity, how to get del theta. So all these things you got, right? If you get
Yes, sir.
similar questions, then you should do it correctly, right?
Yes, sir.
If you cannot do it correctly, then what will I feel? I will feel good.
No, sir.
So you should also think about that. My teacher is working hard for me, but if I don't practice, then if I do mistake or I cannot do it, then my teacher, how he will feel. If you think this way, then I think you will get some inspiration to study, right?
Yes, sir.
Okay, thank you. Now we are going to next question.
Sir, 19.
19. Did you
Some
try
of
this?
the
I gave
yes,
you
sir.
till 20. Did you
Yes,
try?
sir. Yes, sir.
So what is the answer of 19 you got?
Sir, I can't understand the question of 19, sir.
Okay, 19 you did not understand. Fine. Then read.
Some of the liquid in a dish evaporates as shown in the diagram. Which molecules leave the liquid and which molecules in the liquid have greater average kinetic energy?
Okay, wait. Here, as shown in diagrams, you observe this one? Before
Yes, sir.
evaporation and after evaporation, what happens?
Yes, sir.
After evaporation, there is less liquid.
Less liquid.
So the less liquid means some liquids gone, right?
Yes, sir.
Where some liquids gone.
Yes,
Where
sir.
did they go? They go in the air, right?
Yes, sir.
Because they became now gas. That's why they mixed up with the air. Now, uh, when this evaporation happens, what happens to these molecules? Hmm. What happens to these molecules, and
Mhm.
what happens to the molecules they left? They
Yes, sir.
went from here. So, can you remember? Last class we discussed that one. The question related to evaporation. Here you see here which which molecules escape and what happens to the average kinetic energy of the molecules remaining in the liquid. What was the answer for this?
Sir, which one number?
13,
13.
13. Hmm. For 13, we got here 2 points. One is what happens to the uh, which molecules escape. This is one part, and another part is what happens to the average kinetic energy of the molecules remaining in the liquid. So the answer was C, right?
Yes, sir.
The more energetic molecules escape. That means which are leaving from the container, those are more energetic molecules. That's why they are leaving and they are turning to gas or vapor. And the molecules which are left or which are still in the liquid, what happens to them? Their kinetic energy decreases because uh, they give some energy to those molecules, right, to be
Yes,
evaporated.
sir.
Like I gave you example that when we take bath, some liquids are available on our skin. After some time, those liquids leave from our skin and we are feeling cold because those molecules which are leaving from our skin, they are taking energy from our skin, right?
Yes, sir.
So our
Yes,
skin
sir.
is here, like the average kinetic energy of our skin's molecules decreases, like similar thing. That's why we are feeling cold. And uh, the liquid left from our skin, those have more energetic molecules, right? Clear now? Hello?
Yes, sir.
So this
Yes,
similar
sir.
idea we will use there. Look, you are not getting anything new. The notes already you got. and already got some explanation. Those things are coming again and again, but the context is different, different situation, right? But the idea is same. So they are asking you which molecules leave the liquid and which molecules in the liquid have greater average kinetic energy. So which one do you think correct option? Molecules that live, that means which are living, like
Yes, sir.
here we are not having some water, right?
Yes, sir.
So some water or some liquid left, those molecules, what is the condition of them? They have high energy or low energy?
Low energy, sir.
No, we said more energetic molecules leave, right? They are
Mm.
asking about molecules that leave. So they are more energetic molecules. That means low energy or high energy?
Sir, high energy.
High energy. Molecules which are living, of course they have high energy. That's why they are living. Right? Always the molecules which have higher energy, they are moving far apart, right?
Yes,
Isn't
sir.
it? And they are moving far apart means they are becoming gas. That's why they are living. And second column, molecules in the liquid have greater average kinetic energy.
Yes, sir.
So, greater kinetic energy, which have greater kinetic energy. Before evaporation or after evaporation? They are saying in the liquid, not in the gas.
Yes, sir.
Listen. After evaporation, this liquid becomes cold, right? Hello, like
Yes,
your
sir.
skin. After evaporation, these molecules of liquid becomes cold. So cold molecules have less kinetic energy, right? But before evaporation, they are not so cold, right?
Yes, sir.
So before evaporation, they have greater kinetic energy. But after evaporation, they have less kinetic energy, right? So we will take this one before evaporation. As they are asking about the liquid have greater kinetic energy. Which liquids have greater kinetic energy? This one or this one? This, are you understanding, Farabi? What I'm saying?
Yes, sir.
If you don't understand, I will repeat, no problem. We are talking about liquid kinetic energy, right? We have two liquids here. One is here, another one is here, right?
Yes, sir.
So after evaporation, we say this one is cold, right? The liquid left in the container, that one is cold. And if it is cold, then it has less kinetic energy. That means what? Before evaporation, this one has more kinetic energy, right? It is a little bit
Yes,
hotter,
sir.
right? So our option will be what? If I ask you about molecules in the liquid have greater average kinetic energy, that one will be before evaporation, right?
Yes, sir.
So here high energy and here before evaporation. So A is the answer. Clear to you, Parabi?
Yes, sir.
Now, can you explain to me what you understood? Why we are choosing A? Can you explain?
Yes, sir.
Hmm. Just repeat what I told you. Just repeat. Why we are choosing A?
Yes, yes, sir. As the
Hmm.
molecules, as the molecules are converting to gas and they have high energy,
Very good. Very good. Then the next part. Next part you will say this way. After evaporation, the molecules becomes cold, right? The liquid
yes, sir.
becomes cold. That's why we can say before evaporation it is a bit hot, right? Or
Yes,
warm.
sir.
So the molecules before evaporation, liquid molecules before evaporation, they have greater average kinetic energy. Just tell me this one. Okay, tell again, tell again. Try. You say after evaporation. Say with
After
me.
evaporation,
The liquid molecules become cold.
the liquid molecules become cold.
So they have less kinetic energy.
They have less kinetic energy.
Before evaporation, so before evaporation, say so before evaporation,
So before evaporation,
they have greater average kinetic energy.
we have better average kinetic energy.
Is it clear to you now?
Yes, sir.
Okay. So the answer is A.
A.
19. The answer is A. Now 20. 20.
Yes, sir.
Can you try 20?
Yes, sir. An insulted beaker contains 300 grams of water initially at 30 degrees Celsius. Water at 100 degrees Celsius is added until the temperature of the mixture reaches 50 degrees Celsius. The specific heat capacity of water is 4 joules per gram degree Celsius. How
Hmm.
much water is added?
Yeah. So they are asking you the mass, right?
Yes, sir.
So they are asking
Just we
about
need
the
to.
how much water is added. First, first you have to find the mass. Then if you
Yes, sir.
subtract, then you will find subtract with 300 gram. Then we'll get the answer. Okay.
Yes, sir.
So what is the formula for mass? Already we
Formula of
did.
heat cap.
Just now we did. You
Yes,
directly
sir.
tell me the formula of mass because on your copy it should have written, right? Can you tell me the formula?
Yes, sir. Q Q equals to and Latin
Mass for mass.
mass.
Hmm.
M equals to C by nah, M equals to C niche upar M equals to sir one.
Just see and tell me from your previous question.
C equals to Q by M del theta.
Mm-hmm. Yeah,
Q.
that one is the basic, but I am asking you with M. We rearrange the
Oh,
formula, right, for M
M equals to Q by
because
C
we
del theta.
again
Q by C del theta.
Q by C del theta. M equals C, Q by C del theta. So write it again. You write. Please write. M equals again and again you have to write. Then you can
Yes,
memorize it quickly, right? If
yes, sir.
you write it again and again, then one day you will see that all the things are coming quickly in your mind.
Yes,
Otherwise,
sir.
it will not come. M equals Q
Q
by
by C del theta.
C del theta. Yes. So you write all the values.
Yes, sir.
Write all the values and put the values now. Q is which one?
Sir, Q is.
Q is given here.
Yes, sir. Q is. Sir, no, 300 gram. No, no, sir. No, sir. Q is not given.
Just wait. Azan is going on. Just wait. Okay. La ilaha illallah. Farabi,
Yes, sir.
so you don't have
There is
Q.
no,
You
there
don't
is no
have
Q,
Q.
sir. Yes,
So
sir.
how to do it then without Q? We have to find Q, right?
Yes, sir.
Now let's try to find the Q. We have given here M, right, at the beginning.
Yes, sir.
Okay. So this one is the water at 30 degrees Celsius, right?
Yes, sir.
Then water at 100 degrees Celsius added. Clear? Then the final temperature, how much?
The final temperature
50 degrees Celsius. So
50
uh,
degrees
in
Celsius.
your previous questions, you got two temperatures only. But now you got how many temperatures?
3.
Three temperatures. You never got this type of questions, right? That you have
Sir.
three temperatures. You have only two temperatures, theta 2 minus theta 1. So how can you do this? How can you do this, Farabi? You can do it with the
Multiply
same
this.
formula, but now
Sir,
now you have to uh, do it in some parts, some steps. Okay, in some steps. Can you tell me the steps? How can we do it?
So first we need to multiply the temperature.
Look, one thing is here, we have some cold water, right?
Yes, sir.
And this is 30 degrees Celsius water. We have 300 gram water. And we have some hot water, right? So
Yes, yes,
when we are giving hot water with cold water, then cold water is gaining heat, isn't it?
yes, sir.
And the hot water is losing heat. Do you understand this? That
Yes, sir.
hot water is losing and cold water is gaining heat. And at one moment they are reaching to a new same temperature 50 degrees C. After the mix up and after some time they will reach the same temperature, right? It's happening right in your life also, that sometimes we are taking bath in the winter season. It happens, right? In bucket we are taking cold water, and from the stove we are taking hot water, then we are mixing those two water and it reaches to a final temperature.
Yes,
Can
sir.
you remember that one?
Yes, sir.
During the winter it happens. So the cold one you cannot take bath, and the hot one also you cannot take bath. But if you get the mixture one, which one is final temperature, then you can take the bath, right? Is it clear,
Yes, sir.
Farabi?
Yes, sir.
Okay, Farabi, give me just 1 minute. I'm talking to someone. He's calling me. Assalamu alaikum. Abul Kalam Azad. Alhamdulillah, Alhamdulillah, ala kulli hal. ভাইজান, আমাকে একজন ফোন দিছে আজকে যে সে সাবানের প্রজেক্ট, মানে একজন ব্যক্তি আর কি, উনি আগে লাইটের ব্যবসা করতো, এনার্জি ল্যাম্প, তারপরে কয়েলের ব্যবসা করতো, এখন সে সাবানের ব্যবসা করবে আর কি, সাবান বানাবে, সাবান বিক্রি করবে। তো আমি তো আসলে এই দিক দিয়ে দুর্বল, ভাবলাম যে আমার কেমিস্ট বন্ধু আজাদ, তার কাছ থেকে কোনো পরামর্শ নেওয়া যায় কিনা। মানে আমার আর কি তো অভিজ্ঞতা নাই, সে ব্যক্তি তো ইউটিউব দেখে দেখে কিভাবে কিভাবে একটা আইডিয়া নিছে, এখন তার সাবান বানাইছে কিন্তু সাবান জমে না। এখন আমি বললাম যে আপনি সাবান বানাইছেন যে কলের পানি দিয়ে বানাইছেন, ওটাতে তো আয়রন টায়রন থাকে, আরো অনেক খনিজ পদার্থ থাকে, আপনি পুকুরের পানি দিয়ে একটু ট্রাই করেন। হম। তো তাদের তাদের হ্যাঁ, তো আমি এটা বলছি তাকে আপাতত, আর কিন্তু আমি তো আসলে কেমিস্ট না। এখন তার কি কি মিশাইছে, কিসের সাথে কত গ্রাম কি মিশাইছে, সেটাও তো একটা ব্যাপার আছে, পার্সেন্টেজ। হ্যাঁ, কস্টিক সোডা মিশাইতে হবে ফ্যাটের সাথে, আরো কি কি দিতে হবে, পানি দিতে হবে কত গ্রাম, এগুলো একটা রেশিও আছে না। হ্যাঁ, তো এবং ফর্মুলেশন হলে তোমার ওই যে আবার কোনোটাতে আবার দেখা যাবে যে তোমার বেস বেশি হয়ে গেলে তো আবার মানুষ গায়ে দিলে খবর আছে, হ্যাঁ, কাপড় দিতে গেলেও খবর আছে। তো এই জন্য আর কি কেমিস্ট হিসেবে আর কি ভাবছি যে ওখানে আবার গ্লিসারিন মিশাইতে হয় যাতে ত্বকের ক্ষতি না হয়, ঠিক আছে। এগুলা কিছু বিষয় আছে না। তো আমি আর কি ডাইরেক্ট তোমার নাম্বার দিয়ে নেই, আমি বলছি যে আমার এক ফ্রেন্ড আছে, আমি আগে তার কাছ থেকে অনুমতি নেই, যদি সে অনুমতি দেয় যে হ্যাঁ আপনার সাথে আপনাকে নাম্বার দিব, তাইলে আমি নাম্বার দিব, আপনি কথা বলে দেখতে পারেন আর কি তার সাথে। এই জন্য আর কি তোমার কল দিছি। বুঝতে পারছো আজাদ? হ্যাঁ, তো এই জন্যই। আর এখন আমার আসলে ক্লাস চলতেছে অনলাইনে, মাঝখানে তুমি কল দিছো, তো নাইলে আর একটু দেয়া যাইতে পারতাম আর কি। হ্যাঁ, আমি একটু মানে এই তো 9টার পরে ফ্রি হব। হ্যাঁ, মানে 9টার পরে ফ্রি হব ইনশাল্লাহ। ঠিক আছে, সালাম আলাইকুম। হ্যালো ফারাবি।
Yes, sir.
তো we are doing here in 2 steps, right?
Yes,
But
sir.
one thing you can realize that the amount of energy the hot water is losing, that amount is taken by the cold water, right?
Yes, sir.
Uh, that one is clear, right? So there are uh, energy taking and energy giving, right?
Yes, sir.
And what is given, that is also taken.
Yes,
Can
sir.
we tell this way? Hello, Arabi.
Yes, sir. Yes,
So
sir.
there will be Q1 and Q2, right? We can say Q1 equals Q2.
Yes, sir.
Q1 is gaining energy and Q2 is losing energy. Could you please write on your copy, please?
Yes, sir.
Otherwise, you will forget that Q1 is energy gained and Q2 is energy lost, and both are equal in this formula or in this question. Okay, now energy gained, that one is related to 300 gram, right?
Yes, sir.
So this one, as it is Q1, uh, we can write the formula Q equals MC del theta, right?
Yes,
Q
sir.
Q equals MC del theta. M is different here because here we have 300 gram. Then C is same because we are using water only, right? Here we are using water and we are also uh, adding some water. So water has always same specific heat capacity, right? And we have
Yes, sir.
here del theta. Del theta is different. One is del theta 1, another one is del theta 2. So del theta will be different. Now we will formula we'll write first, then we will put the values. First you write here M1, right here M1, M1, C same I told you specific heat capacity, then del theta, del theta 1. Okay, this one is del theta 1. So what will be the other one? The right side one, Farabi? Hello, Farabi. Farabi. Hello, Farabi. Farabi. Farabi, you lost the connection. Farabi,
Hello, sir.
you lost the connection.
Yes, sir.
So you got here M1 C del theta 1, right? For Q1.
Yes, sir.
For Q2, what will be giving? Or what you will get?
Mm,
M2, M2, C will be same, right? Parabi,
Yes, sir.
C del theta 2. Okay, Parabi.
Yes, sir.
Now, in both sides, we have C. We can cut it.
Yes, sir.
C can be cut. Okay. What we are going to find? M2, right?
Yes, sir.
How much water is added? That is M2 we are going to find. So we will make M2 as the subject. Then
Yes, sir.
what will we do? We will take del theta to here. M1,
Yes, sir.
M1. So we are writing here M1 del theta 1 divided by what? Del theta 2, right?
Yes, sir.
This way you write. Please on your copy you
Yes,
also write.
sir.
Then you can recall. This is a exceptional question. This is an exceptional question, a difficult question. So you have to practice it again and again. Then M2, right? Both
Yes,
sides
sir.
C is gone. Now we have here only M2. So if you put these values, we will get the answer M2. Now, what is del theta 1? What is del theta 2? You see, here we have 30 degrees initial temperature, and what is final temperature? This one, 50 degree, right?
Yes,
So
yes,
when it's gaining temperature, it was 30 degrees Celsius and its final temperature is 50 degrees Celsius. Then we will subtract 50 minus 30. It will be 20, right?
yes,
So
sir.
here I am writing this one. M1 equals uh, M2 we are going to find, right?
Sir, after this question, can you end the class?
Sorry.
My phone will be shut down within half an hour. Sir, after this question, can you end the class? My phone will be off for
Yes, yes,
within
yes. Yes, after this question we will
20 minutes.
stop the
Less
class.
charge.
No problem. No problem. So M1 is how much? M1 is given 300, right?
Yes, sir.
So write it 300. Then theta 1 how much? Del theta 1. Del theta 1 is 50 minus 30. I told you, right?
Yes, sir.
So I'm writing it here. 50 minus 30 is 20 degrees Celsius, right? 20. In your copy, you write that del in a separate place. You write del theta 1 equals 50 minus 30. Here you write 20, but other place you write theta 1 equals 50 minus 30. Did you write
Yes,
in
sir.
your copy? Please write this way in a separate place. Theta 1 equals 50 del theta 1, actually not theta 1, del theta 1. Right here, del theta 1 is 50 minus 30, huh?
Yes,
50 minus 30. Okay. Then del theta 2, how much? One is I am showing, another one you do, huh?
yes, sir.
Another one also you write del theta 2 equals how much? Del theta will be
Ah,
100 minus 50, okay? The
yes,
final
sir.
temperature
50.
is 50 and the initial temperature is 100, so 100 minus 50 will be how much?
50.
50.
50.
So write it here
120.
50. Del theta 2 is 50. Okay?
Yes, sir.
So what is the answer coming? Can you check please?
Yes,
300
sir.
multiplied by
120.
220. 1?
120.
Okay, very good. So you got the answer. 120 grams. So how much water is added? That is 120 grams. Clear now?
Yes, sir.
So you are becoming a scientist, right? Arabi? Little scientist. We discussed a very, deep questions today. That means we need deep knowledge to understand it. Many O-level students, they also sometimes become puzzled to do this type of questions. Okay, Parabi.
Yes, sir.
So if you want to be expert in this type of questions, you have to practice again and again. Okay.
Yes, sir.
Do you think by today's class you are becoming more knowledgeable,
Yes, sir.
more confident?
Yes, sir.
Okay, thank you. So I'm giving you more homework, right? You finish all the MCQs left.
Yes, sir.
You try to finish all the MCQs left. Try them. Okay,
Okay, sir.
Parabi,
Okay, sir.
thank you so much for joining. Allah Hafiz.
Yes, sir. Yes, sir.